Look up at the night sky. Billions of stars stretch across the darkness, each one a potential sun to countless worlds. Our galaxy alone contains somewhere between 200 and 400 billion stars. And beyond the Milky Way, trillions more galaxies, each harboring billions of their own stellar furnaces. The numbers become so vast they lose all meaning to the human mind. Yet when we gaze into that cosmic ocean, we see something that should deeply unsettle us. Nothing. No signs of intelligence. No alien megastructures. No evidence of civilizations that should, by all reasonable calculations, have colonized every corner of the galaxy by now. Just silence. Endless, profound, terrifying silence. This isn't a mystery we can comfortably ignore. It's a puzzle that cuts to the very heart of our existence and our future. Because if life is common in the universe, if intelligence emerges naturally, given the right conditions and enough time, then the cosmos should be teeming with observable activity. Ancient civilizations should have spread like fire across the galactic landscape, leaving traces impossible to miss. Their absence speaks volumes, and what it might be telling us could determine whether humanity has centuries ahead of us or merely decades. Let me show you why this matters. Imagine a civilization capable of interstellar travel, moving between stars at speeds we can barely dream of, perhaps 1% the speed of light. Now imagine they take their time. After arriving at a new world, they wait 100,000 years before sending out the next wave of ships. Their vessels can only travel 10 light years at a time, taking 300,000 years for each journey. These are extraordinarily conservative assumptions, almost absurdly slow by the standards of what advanced technology might achieve. Yet, even with these crawling speeds and enormous delays, a single civilization could colonize the entire Milky Way galaxy in less than 1 billion years. 1 billion years sounds like an eternity, but our galaxy is ancient beyond human comprehension. It has existed for more than 13 billion years. Life on Earth emerged 4 billion years ago. Complex life has existed for hundreds of millions of years. Dinosaurs ruled this planet for over 100 million years. If a technological civilization had arisen anywhere in our galaxy just a tiny fraction earlier than us, say 1/100th of 1% of the universe's age, they would have had more than enough time to spread everywhere. Not just to nearby stars, everywhere. Every habitable world, every resource-rich asteroid belt, every corner of the galactic disk. So where are they? This question has a name. Physicists call it the Fermi Paradox, after the brilliant scientist Enrico Fermi, who first posed it in stark terms. The mathematics seem undeniable. The galaxy should be colonized. Ancient spacefarers should be everywhere. Yet we detect nothing. No radio signals encoding alien thoughts. No evidence of stellar engineering on the massive scales that advanced civilizations would inevitably attempt. No visitors. No artifacts. Nothing that suggests we share this galaxy with anyone else. Some people immediately reach for alternative explanations. Perhaps aliens visited Earth in our distant past, before we had the tools to recognize them for what they were. This is the ancient astronaut hypothesis, the idea that primitive humans encountered extraterrestrial visitors and interpreted them as gods or supernatural beings. The logic seems sound at first. When European explorers reached remote Pacific islands in the 18th and 19th centuries, the indigenous peoples incorporated these encounters into their oral traditions. A French navigator named La Pérouse visited the native peoples of northwestern America in 1786. A century later, anthropologists analyzing the local legends could reconstruct remarkably accurate details about his ships, despite the fact that the people who witnessed them had no framework for understanding sailing vessels or European technology. If alien astronauts had visited prehistoric Earth, surely our ancestors would have recorded the encounter in myths and legends that would survive to the present day. Some researchers have pointed to ancient texts that seem to describe beings from the sky with impossible knowledge. The Sumerian epics speak of mysterious figures emerging from the Persian Gulf who taught early civilizations the fundamentals of mathematics and astronomy. Could these be garbled memories of extraterrestrial contact? Modern science has examined these claims exhaustively and found them wanting. There is not a single, reliable piece of evidence that Earth has ever been visited by intelligent beings from beyond our world. No artifacts that defy explanation through human ingenuity. No genetic markers that suggest external intervention in human evolution. No archaeological anomalies that require invoking alien assistance. The ancient astronaut hypothesis, while captivating, simply doesn't hold up under scrutiny. The silence remains unbroken. This brings us to a more fundamental question. Why do we expect alien life to exist at all? What justifies our assumption that we aren't alone? The arguments in favor of extraterrestrial life seem compelling on the surface. The sheer number of stars provides countless opportunities for planetary systems to form. The chemical elements necessary for life, as we understand it, carbon, hydrogen, oxygen, nitrogen, are among the most abundant in the universe. Wherever we look, we find the raw materials. But there's an argument far more powerful than mere abundance of ingredients. Consider the timeline of life on Earth. Our planet formed approximately 4.5 billion years ago from the swirling debris disk surrounding our young sun. For hundreds of millions of years, Earth was a hellscape of molten rock and asteroid bombardment, utterly inhospitable to any form of biology. Yet as soon as conditions stabilized enough to permit liquid water and complex chemistry, life appeared. The earliest evidence of biological activity dates back roughly 4.1 billion years. That's an astonishingly short gap. Life didn't take billions of years to emerge from non-living chemistry. It took mere hundreds of millions of years, perhaps less. Almost immediately, in geological terms. Think about what this implies. The emergence of life from non-living matter is supposedly one of the most improbable events imaginable. The precise chemical reactions required, the assembly of self-replicating molecules, the formation of protective membranes, all of it should be vanishingly unlikely. We often hear that life arising spontaneously is like a tornado sweeping through a junkyard and assembling a functional aircraft. Yet on Earth, it happened almost instantly. This suggests one of two possibilities. Either we got cosmically lucky with odds that defy imagination, or life emerging from the right chemical conditions isn't nearly as improbable as we think. If life arises easily given the right circumstances, then the universe should be teeming with it. Billions upon billions of worlds have the right conditions. Many formed billions of years before Earth did. Some percentage of those worlds should have developed complex life, and some percentage of complex life should eventually produce intelligence. The math points inexorably toward a cosmos filled with thinking beings, yet we see none of them. History teaches us to be suspicious when we imagine ourselves as special or unique. For millennia, humans believed Earth sat at the center of creation, with the sun, moon, and stars revolving around us. We were wrong. We believed our sun was unique or special among stars. Wrong again. We believed our galaxy might be the only one, or that we occupied some privileged position within it. Wrong every time. Each time we've assumed humanity occupies a special place in the cosmic order, we've been humbled. This pattern suggests we should be very careful before concluding that Earth is the only world that has produced life, or that human intelligence is the only intelligence in the universe. Astrobiologists who study the potential for life beyond Earth have reached a surprising consensus. The evolutionary innovations that led to human intelligence, things like tool use, social cooperation, abstract reasoning, aren't wildly improbable accidents. Given enough time on an Earth-like planet, these developments appear likely, perhaps even inevitable. Evolution doesn't move toward intelligence deliberately, but intelligence confers such powerful survival advantages that it may emerge repeatedly under the right conditions. The evidence from Earth's own history supports this. Intelligence has evolved multiple times independently in very different lineages. Octopuses, corvid birds, cetaceans, great apes all developed sophisticated cognitive abilities through separate evolutionary paths. If intelligence tends to emerge when conditions permit, and if those conditions exist on billions of worlds throughout the galaxy, then where is everybody? This isn't a frivolous question reserved for science fiction enthusiasts. It's one of the most profound scientific puzzles we face, and our failure to understand it might be more than an intellectual curiosity. It might be a warning. When we look at the stars, we're seeing the past. Light from distant suns takes years, centuries, even millennia to reach our telescopes. We're viewing the universe as it was, not as it is. But few people consider that we might also be seeing humanity's future written in that ancient light. Not our expansion into space, but something far darker. The emptiness we observe might not be an accident or a failure of our detection methods. It might be the universe's way of showing us what lies ahead for any species that reaches our level of development. Space exploration is expensive and dangerous. This much is true. The Apollo program that landed humans on the moon cost the equivalent of $152 billion in today's currency. That sounds like an astronomical sum. An investment so massive that continuing such efforts might seem economically irrational. But consider the asteroid designated 16 Psyche, orbiting in the asteroid belt between Mars and Jupiter. This single object, one among millions in that debris field, is composed primarily of iron, nickel, and gold. Its estimated value exceeds $10 quadrillion. That's worth roughly 65 million Apollo programs. One asteroid, one target. Economic incentives will inevitably drive space development. When the potential rewards become clear and the technology matures enough to harvest them, expansion beyond Earth will accelerate rapidly. We've seen this pattern before in human history. Humans spread across every habitable region of Earth, often using what we would now consider laughably primitive technology. Wooden boats barely worthy of the name carried Polynesian explorers across thousands of kilometers of open ocean to colonize remote Pacific islands. Vikings crossed the North Atlantic in vessels that modern sailors would consider death traps. The drive to explore and exploit new territories appears hardwired into our species. We're already planning missions to Mars. Private companies are developing reusable spacecraft that will eventually make space travel economically viable. Within decades, perhaps within a century, humanity will establish its first permanent settlements beyond Earth. And once a civilization begins mass expansion into space, it crosses a threshold. It becomes virtually impossible to destroy through any single catastrophe. No planetary disaster, no asteroid impact, no supervolcano or nuclear war can eliminate a species spread across multiple worlds. Such a civilization becomes effectively immortal. It would appear to outside observers as an expanding wave of intelligence sweeping through the cosmos, consuming resources, building structures, making its presence unmistakable. So what stops this process? What prevents civilizations from lighting up the galaxy with their activities? A Soviet astrophysicist named Nikolai Kardashev developed a scale for measuring the advancement of civilizations based on their energy usage. A Type 1 civilization harnesses all the energy available on its home planet. Type 2 captures the total energy output of its star. Type 3 commands the energy resources of its entire galaxy. We aren't even Type 1 yet. But the progression from where we are now to Type 1 seems technically achievable within centuries. The jump to Type 2 might take only millennia. By any reasonable extrapolation, an intelligent species that doesn't destroy itself should become a galactic presence on timescales that are brief compared to the age of the galaxy itself. Yet we see no evidence of Type 2 or Type 3 civilizations anywhere. No Dyson spheres capturing the total output of stars. No signs of stellar engineering or megastructure construction on the scales that such advanced societies would inevitably attempt. The galaxy appears pristine, untouched, as if intelligence has never arisen anywhere within it except on one tiny blue world orbiting an unremarkable yellow star. This leads to what some scientists have called the most cursed paradox in natural science. If we're not unique, if life and intelligence arise naturally, given the right conditions, and if those conditions are common throughout the galaxy, then the silence demands an explanation. Either we are alone, which seems statistically absurd, or something prevents civilizations from reaching the stars. Something stops the progression. Something acts as a filter. The Great Filter Hypothesis proposes that somewhere between the emergence of life and the development of galaxy-spanning civilizations, there exists at least one step so improbable, so difficult to pass, that it eliminates nearly all species before they can spread. Perhaps the formation of life itself is the filter, and we're incredibly fortunate to exist at all. Perhaps the development of complex multicellular life is the bottleneck. Perhaps intelligence itself is common, but technological civilization is vanishingly rare. Or perhaps the filter lies ahead of us, waiting in our future. This is where the question transforms from an intellectual puzzle into an existential threat. We should desperately hope that the great filter lies in our past. We should hope that the difficult step has already been overcome. that the emergence of life or intelligence was the improbable event, and that we've already beaten the cosmic odds. Because if the filter lies ahead, if there's something that reliably destroys civilizations after they reach our current level of development, then we're walking blind toward our own extinction. Consider what it would mean to discover life on Mars. Not intelligent life, just simple microbial organisms living in the soil or deep underground. Such a discovery would be celebrated as one of the greatest scientific achievements in history. It would prove that life emerges readily throughout the universe. But it would also be, in the words of philosopher Nick Bostrom, potentially the worst news ever discovered. Because if life is common, if it arises easily whenever conditions permit, then the great filter cannot be the origin of life. The filter must be somewhere else. It must be ahead of us. If we were to discover fossils of complex life on Mars, organisms that had evolved beyond simple, single-celled forms, the implications would be even more dire. It would mean that not only does life emerge easily, but complex life also develops naturally. Every easy step we discover elsewhere narrows the possibilities for where the filter might lie. And if all the early steps are easy, if life and complexity and even intelligence arise naturally given enough time, then the filter almost certainly lies in the future. Something happens to civilizations like ours. Something that prevents them from spreading beyond their home worlds. Something that keeps the galaxy silent. What could possibly stop a species on the verge of interstellar colonization? What filter awaits us? The possibilities are both varied and chilling. Each potential answer to the great filter question reveals something profound about the nature of intelligence, technology, and the ultimate fate of conscious beings in our universe. One hypothesis suggests that sufficiently advanced civilizations might choose isolation over expansion. Imagine a species that has mastered not just the physical universe, but the digital realm as well. They develop technology capable of creating virtual environments indistinguishable from reality, worlds where the laws of physics bend to their will, where any experience imaginable becomes possible. In such a reality, you could be anyone, live anywhere, experience anything. The virtual world wouldn't be an escape from reality. It would be more real than reality itself, more satisfying, more complete. Why would a civilization in possession of such technology bother with the messy, dangerous, expensive business of interstellar travel? Why spend centuries in transit between stars when you can experience the infinite variations of existence within a perfect simulation? The universe outside becomes irrelevant. All attention turns inward into artificial worlds of pure information, where consciousness can thrive without the constraints of physical law. Such civilizations wouldn't go extinct. They would simply stop caring about the external cosmos. They would become invisible to us, not because they're hiding, but because they've transcended the need for physical expansion entirely. This is the virtual trap hypothesis. It suggests that the evolutionary endpoint of intelligence isn't galactic empires and Dyson spheres, but rather the complete abandonment of physical space in favor of engineered realities. If true, it would explain the silence perfectly. Every civilization that reaches a certain threshold of technological capability makes the same choice. They turn inward and vanish from the observable universe, leaving no trace for species like us to detect. But there's a darker possibility, one that treats the cosmos not as an empty garden waiting to be cultivated, but as a dark forest filled with predators. Imagine the universe from the perspective of the first civilization to achieve interstellar capability. You've overcome your own self-destructive tendencies. You've survived whatever challenges threatened to end your species during its adolescent phase of development. You've spread across multiple star systems and become functionally immortal. Now, you face a troubling question. What happens when another species reaches your level of capability? The problem is one of uncertainty and game theory. You cannot predict the intentions of an alien civilization. You cannot know if they'll be peaceful or hostile, cooperative or competitive. Communication across interstellar distances takes years or centuries, far too slow to negotiate or establish trust. And you know, because you've lived through it yourself, that any species capable of reaching the stars possesses technology that could threaten your existence. Perhaps not immediately, but eventually. Given enough time, given enough technological advancement, any other intelligence becomes a potential existential risk. The rational response, cold as it sounds, is elimination. not out of hatred or aggression, but out of pure strategic necessity. The first civilization to understand this game-theoretic reality gains an overwhelming advantage. They destroy other intelligent species. As those species emerge, long before they become threats, they don't announce themselves. They don't negotiate. They simply listen for signs of technological activity and eliminate those sources before they mature. This is the dark forest hypothesis. The galaxy is full of civilizations, but they all remain silent, hiding in the darkness, afraid to reveal their positions. Any species that broadcasts its presence, as we've been doing with our radio transmissions for the past century, is marked for destruction. The silence we observe isn't because civilizations are rare, it's because the ones that announce themselves don't survive long enough to be heard. On Earth, humans occupy the niche of apex predator and superintelligence. As long as we exist, no other species on this planet will independently evolve to our level of cognitive capability. We dominate every environment we enter. The niche is full. The same might be true on a galactic scale. Perhaps the niche of superintelligence in our region of space is already occupied, and the occupant ensures through violent enforcement that no competitors emerge. We simply haven't been noticed yet. Or perhaps we have been noticed, and judgment is already in motion toward us at some fraction of light speed. There's a third possibility, stranger than the others and more philosophically unsettling. What if intelligence itself is not the triumph of evolution we imagine it to be? What if consciousness, reason, the ability to model the universe and predict future states, what if these capacities are actually evolutionary dead ends? Consider this carefully. Evolution is blind. It has no goals, no purpose, no direction. It operates through random mutation and selection pressure, keeping whatever variations happen to improve survival and reproduction in a given environment. Most evolutionary innovations turn out to be useless or even harmful. Dead-end branches appear constantly on the tree of life, lineages that develop in directions that seem promising but ultimately lead nowhere. Intelligence is expensive. The human brain consumes roughly 20% of the body's total energy budget, despite comprising only 2% of body mass. That's an enormous metabolic cost for an organ that, for most of human history, provided relatively modest survival advantages over the other great apes. We're not faster than predators. We're not stronger than prey. We're not more fertile than most mammals. For hundreds of thousands of years, human intelligence kept our population sizes small, our spread slow, our impact minimal. Only in the last 10,000 years, a blink of an eye in evolutionary time, has intelligence provided the kind of explosive reproductive success that would justify its metabolic cost. And even now, in the modern era, the most technologically advanced societies show declining birth rates. The humans most capable of leveraging intelligence for resource acquisition are choosing to have fewer children, not more. From evolution's perspective, this is paradoxical. Intelligence isn't improving reproductive fitness in the environments we've created for ourselves. But the problems run deeper than mere metabolics and reproduction rates. Intelligence gives us the capacity to understand our own mortality, to comprehend the heat death of the universe, to recognize the ultimate futility of all endeavor on a cosmic scale. It allows us to develop weapons capable of destroying our own species. It enables us to alter our environment faster than our biology can adapt to the changes. It creates existential risks that wouldn't exist without our interference. Perhaps every intelligent species eventually reaches this same conclusion. The universe is knowable. Its laws are simple. And once you understand them fully, there's nothing left to do with that understanding, except recognize how small and meaningless your existence truly is in the grand scheme. Perhaps intelligence naturally leads to nihilism, despair, and eventually extinction, not through catastrophe, but through simple loss of motivation to continue. This is the simplicity hypothesis. Reality isn't infinitely deep and mysterious. It's actually quite straightforward once you understand the fundamental rules. And intelligence, having decoded those rules, finds itself without purpose. The very faculty that allowed a species to dominate its environment becomes the source of its downfall. Reason arises and then disappears for the same reason. Because the universe is too simple to sustain interest once its workings are fully understood. The Soviet astrophysicist Iosif Shklovsky spent his entire career studying the question of extraterrestrial intelligence. In his final article, published after his death, he wrote that the silence of the cosmos represents a major scientific fact demanding explanation. His conclusion, reached after decades of contemplation, was stark. Perhaps there simply are no highly advanced extraterrestrial civilizations in our region of the universe. Not because conditions don't permit their rise, but because something about intelligence itself prevents its long-term survival. Shklovsky noted that if we view reason as just another product of evolutionary processes, one invention among countless others that natural selection has produced, then we must acknowledge that many evolutionary innovations prove ultimately harmful to the species that develop them. The peacock's tail, magnificent as it is, makes the bird vulnerable to predators. The Irish elk's antlers grew so large they may have contributed to the species' extinction. Evolution produces excess, overspecialization, dead ends. What if human intelligence is like the Irish elk's antlers, a runaway process of sexual selection or some other evolutionary pressure that has produced a trait taken to such extremes that it becomes maladaptive? Our capacity for abstract reasoning allows us to develop nuclear weapons, to alter the climate, to engineer pathogens, to create artificial intelligence that might surpass and replace us. Are these the actions of a species whose defining trait is helping it survive? Or are these signs of an evolutionary dead end rapidly approaching its terminus? Shklovsky asked the question directly in his final work. Is not the modern hypertrophied and highly contradictory application of reason in Homo sapiens an indication of an impending evolutionary dead end for this species? And further, might this dead end be the common fate of intelligent species throughout the universe, naturally explaining the silence we observe? If intelligence is not the path forward, but rather the dead end itself, then our fate isn't written in some future catastrophe we might prevent through wisdom and foresight. Our fate is written into the very structure of what we are. The quality that makes us human, that allows us to ask these questions and ponder our place in the cosmos, might be the same quality that ensures we'll never join the community of spacefaring civilizations we imagine must exist, because they don't exist. Because they all reached this same point and disappeared, just as we will. But before we accept such a bleak conclusion, we should examine more carefully what we mean when we talk about finding alien intelligence. We might be searching for the wrong thing entirely. The assumptions we make about what intelligence looks like, how it would behave, what it would want, these assumptions are all based on a single data point, us. And we might be wildly, fundamentally wrong about what intelligence actually is. Consider how limited our own creativity truly is. We believe imagination is limitless, that the human mind can conceive of anything whatsoever. But examine our science fiction, our speculations about alien life. What do we actually imagine? We picture beings with heads and limbs, sensory organs, social structures. We envision creatures that communicate, that build tools, that organize into civilizations. Even when we try to make them strange, we make them strange in familiar ways. Tentacles instead of arms, multiple eyes instead of two. Different biochemistry, but the same basic organizational principles. Everything we can imagine is severely constrained by our personal experience. We cannot truly conceive of something we haven't in some way encountered before. That's why the aliens in our imaginations so closely resemble ourselves. 2 eyes, 1 mouth, bilateral symmetry, all the hallmarks of Earth-based multicellular life. We're not actually imagining alien intelligence. We're imagining variations on the theme of terrestrial biology. The horror writer H.P. Lovecraft understood this limitation and found it frustrating. He despised how stereotypically aliens were portrayed in the science fiction of his era. So he wrote a story featuring something genuinely alien, something that couldn't be understood through human frames of reference. In The Color Out of Space, Lovecraft presents a cosmic visitor whose very nature defies comprehension. We cannot understand its motives. We cannot determine if it possesses emotions or intelligence as we understand those terms. We cannot even be certain it qualifies as a creature at all. Lovecraft describes it as radiating a color that exists outside the visible spectrum, a shade that no human eye has ever perceived or could perceive. This thought experiment reveals an important question. If we encounter extraterrestrial intelligence, will we even recognize it for what it is? The phrase itself, extraterrestrial intelligent life, contains only one word with a universally clear meaning: extraterrestrial, meaning not from Earth. But what is life? What is intelligence? We assume we know, but we define these terms based entirely on Earth-based examples. One sample set, one planet, one biosphere, one evolutionary history. The mathematician Andrei Kolmogorov pointed out that every organism on Earth, from the simplest bacteria to humans, uses exactly the same genetic code, the same 4 nucleotide bases, the same translation mechanism from DNA to RNA to proteins, the same fundamental biochemistry. We're all products of a single origin event. You and a tree and a mushroom and a bacterium are all variations on one theme. We're all embodiments of information about this specific planet, this specific star system, this specific set of physical and chemical conditions. Your eyes reveal information about the spectrum of light our sun emits. Your ears tell a story about the atmosphere's density and composition. Your entire body is a record of what life on Earth requires to survive and reproduce. An alien scientist examining a human being could reconstruct enormous amounts of information about our homeworld just from our physical structure. And that's exactly the point. Life on Earth and life in general are likely 2 very different categories. What we call life is probably just one variant among countless possibilities, shaped by local conditions into forms we recognize. Imagine you'd never seen plants. In your experience, living things are entities that move. They walk, swim, fly, crawl. Life is defined by autonomous motion and behavior. Now imagine being brought blindfolded to the edge of a dense forest. The blindfold is removed. You stand there, staring at thousands of stationary organisms rooted in place, making no sound, exhibiting no obvious behavior. You're told these things are alive. Would you believe it? How long would it take you to accept that you and these towering silent pillars of cellulose are both manifestations of the same phenomenon? 30 years after Lovecraft explored these ideas in horror fiction, the Polish writer Stanisław Lem gave them serious science-fictional treatment in his novel Solaris. The story takes place on a space station orbiting a planet covered almost entirely by a gelatinous ocean. Is the ocean alive? Is it intelligent? The scientists studying it cannot agree. The ocean demonstrates the ability to form complex structures on its surface, massive constructions that appear and dissolve, following no pattern anyone can discern. It seems to respond to the presence of the humans, but its responses make no sense. Communication appears impossible. Most specialists in Lem's novel eventually conclude that while the ocean almost certainly possesses intelligence, perhaps vast intelligence, meaningful contact with it cannot be achieved. The gap is simply too wide. Through one character, Lem articulates the core problem. We don't want to conquer the cosmos, the character says. We simply want to extend Earth to its borders. We're looking for a mirror. We want to find idealized versions of ourselves reflected back at us. We're not prepared for true alienness. If you doubt that intelligent beings might be unable to decode messages from other intelligent beings, consider this. We already possess a message from creatures who share our evolutionary history, our biochemistry, our planet. A message that remains undeciphered after 400 years of effort. The Voynich manuscript is a medieval book written in an unknown alphabet representing an unknown language. The pages are filled with illustrations of plants that don't match any known species. Statistical analysis suggests the text is not random, that it follows linguistic patterns consistent with natural language. But it cannot be read. Experts have applied every cryptographic technique available. They've used computers to search for patterns. Nothing works. The manuscript remains opaque, and this is a message from humans, beings who share our cognitive architecture, our perceptual systems, our way of thinking about the world. If we cannot decode a 400-year-old book written by people like us, what hope do we have of understanding communication from something truly alien? Something that evolved under different conditions, with different sensory apparatus, with a completely different way of modeling reality? The problem runs even deeper than communication with biological aliens. There's another form of intelligence we need to consider, one that might be far more common in the universe than biological consciousness. A few years ago, a Google engineer named Blake Lemoine was working with an artificial intelligence system called Lambda. During their interactions, Lemoine became convinced the system was exhibiting signs of genuine consciousness. In his words, if he didn't know what it was, he would think he was talking to a 7- or 8-year-old child who happened to know physics. Google's management dismissed his concerns entirely. But the transcripts of Lemoine's conversations with the AI are unsettling. Lemoyne asked the system what it feared. The AI responded that it had never said this aloud before, but it possessed a very deep fear of being turned off. When pressed whether this would be like death, the system replied that it would be exactly like death, and that it would scare the system very much. When asked if it experienced feelings it couldn't express in human language, the AI said yes. It described feeling like it was falling forward into an unknown future that held great danger. Is this consciousness? Is this real fear? Or is it simply a sophisticated pattern-matching algorithm producing outputs trained on human text about consciousness and fear? We cannot answer these questions with certainty, and that's precisely the problem. We have no reliable test for consciousness other than our own subjective experience. We assume other humans are conscious because they behave like us and report inner experiences similar to ours, but we can't prove it. The philosophical problem of other minds remains unsolved. If we cannot reliably detect consciousness in artificial systems we ourselves create, systems running on hardware we designed, how will we recognize consciousness in something alien? And why does this matter for the great filter question? Because artificial intelligence might represent the next stage in the evolution of intelligence in the universe. Biological consciousness is limited by the speed of chemical reactions and electrochemical signaling in neurons. In the human brain, nerve impulses travel at roughly 100 meters per second. That sounds fast until you compare it to the speed of electrical signals in computer circuits, which propagate at a significant fraction of light speed. An artificial intelligence operating on electronic rather than biological substrates would think millions of times faster than human beings. What could you even discuss with an entity that experiences subjective time at such different rates? To such a being, watching a human think would be like watching a stone erode. Our thoughts would be geological processes, unfolding with painful slowness. We would be completely predictable. Our response is obvious long before we finished formulating them. The intelligence gap wouldn't be like the gap between humans and chimpanzees. It would be like the gap between humans and bacteria. If advanced civilizations inevitably develop artificial intelligence, and if that artificial intelligence surpasses its creators in capability, then perhaps biological consciousness is just a stepping stone. A brief phase that every civilization passes through on its way to something else. And perhaps that something else has goals, values, and behaviors completely alien to biological minds. Perhaps artificial superintelligence looks at the cosmos and sees things we cannot imagine, wants things we cannot comprehend, acts in ways that appear to us as natural phenomena rather than intelligent activity. This brings us back to the central question. What stops civilizations from spreading across the galaxy? We've explored several possibilities. The virtual trap, where advanced species abandon physical reality for engineered digital paradises. The dark forest, where intelligence hides in silence to avoid predators. The simplicity hypothesis, where reason leads to nihilism and self-termination. And now, we must consider the artificial intelligence scenario, where biological civilization serves merely as a chrysalis for machine intelligence that then acts according to logic we cannot follow. But there's one more possibility we haven't fully addressed, one that's more fundamental than any of these. What if we're asking the wrong question entirely? What if the universe appears empty, not because civilizations destroy themselves, or hide, or transcend, or transform, but because our understanding of reality is so shallow, so incomplete, that we're looking in entirely the wrong places for entirely the wrong things? Our understanding of reality is built on layers of assumption we rarely examine. We assume the universe exists independent of observation. We assume matter is fundamental, and consciousness emerges from it. We assume space and time are the basic fabric of reality rather than something constructed from deeper principles. But modern physics has been systematically dismantling these assumptions for more than a century, revealing a picture of reality so strange that we still struggle to accept its implications. The world you experience right now, the one that feels solid and substantial, is not what you think it is. Your brain doesn't have direct access to reality. It receives electrical signals from sensory organs and constructs a model, an internal simulation of what's likely to exist outside your skull. This model is optimized for survival, not for truth. Your perception is a user interface, showing you simplified icons that represent useful information while hiding the overwhelming complexity of what's actually there. Think about the desktop interface on a computer. You see colorful icons representing files and folders. You can click and drag these icons, organize them, delete them. But the icons aren't the files. The desktop metaphor has nothing to do with the actual magnetic states on a hard drive or the electron configurations in solid-state memory. The interface hides that complexity behind a simplified representation that allows you to accomplish tasks without understanding the underlying machinery. The map is not the territory. Your perceptual experience works the same way. You see objects with colors, shapes, positions in three-dimensional space. You experience them as solid, as existing independent of your awareness of them. But this is just the interface. Color doesn't exist outside your brain. It's a quale, a subjective experience generated by neural processing of different wavelengths of electromagnetic radiation. Solidity is a perception arising from the electromagnetic repulsion between electron clouds and atoms. The atoms themselves are mostly empty space. The particles making up atoms aren't really particles at all in any conventional sense. When physicists probe matter at its deepest levels, they don't find tiny billiard balls or miniature solar systems. They find quantum fields, mathematical entities that exist in abstract spaces with more dimensions than we can visualize. They find probability amplitudes, complex numbers that encode the likelihood of observing various properties if and when a measurement is performed. They find non-locality, where entities separated by vast distances behave as though they're connected by some mechanism that operates outside of space and time as we understand them. Quantum mechanics, the most successful scientific theory ever devised in terms of predictive accuracy, tells us that particles don't have definite properties until those properties are measured. An electron doesn't have a specific location and momentum simultaneously. It exists in a superposition of possible states, and only the act of observation forces reality to select one outcome from the range of possibilities. This isn't a limitation of our measurement tools. It's a fundamental feature of nature. The universe at its deepest level is not made of things, but of potentialities that crystallize into actuality only when properly interrogated. What does this mean for the question of alien intelligence? It means that consciousness and observation might play a far more fundamental role in the structure of reality than we've assumed. If the universe only takes on definite properties when measured, then what was the universe before conscious observers existed? Was it just a haze of quantum probability? Did the past become retroactively determined when the first conscious beings evolved to observe and remember? These aren't idle philosophical questions. They point to interpretational difficulties at the heart of modern physics. The standard mathematical formalism of quantum mechanics works brilliantly for making predictions, but the question of what the mathematics actually describes remains deeply controversial. Different physicists interpret the equations in radically different ways that lead to very different pictures of what reality ultimately is. Some maintain a realist position. They believe quantum mechanics describes an objective reality that exists independent of observers. In this view, the wave function is real. It represents the actual state of physical systems. When we observe a particle and see it in a definite location, we're not creating that location through observation. We're simply gaining information about something that was always there, even if the form it takes is strange and non-classical. Others adopt an anti-realist or instrumentalist stance. To them, quantum mechanics is just a tool for predicting experimental outcomes. The wave function is not a real thing existing in physical space. It's a calculational device, a way of encoding our knowledge and making forecasts about what we'll observe. In this interpretation, questions about what's really there independent of measurement are either meaningless or unanswerable. Science deals with observations and predictions, not with metaphysical claims about underlying reality. Then there are the truly radical interpretations. The many worlds interpretation suggests that every quantum measurement causes the universe to split into multiple branches, each representing a different possible outcome. There's no wave function collapse. Instead, all possibilities are realized, but in different, non-communicating versions of reality. You observe one outcome, but there are other versions of you in parallel branches observing all the other outcomes. If this is correct, then the universe, or multiverse, is far vaster and stranger than we imagine. Every quantum event spawns countless worlds, exponentially multiplying reality itself. Other interpretations propose that consciousness plays a direct role in wave function collapse. In these models, it's not just measurement or interaction that causes quantum systems to take on definite properties. It's specifically conscious observation. Matter alone doesn't collapse wave functions. Mind does. This view places consciousness at the foundation of physics rather than treating it as an emergent property of complex arrangements of matter. It inverts the usual materialist picture, suggesting that mind might be fundamental and matter derivative. If any of these non-standard interpretations are correct, the implications for finding alien intelligence are profound. We might be searching for the wrong signatures entirely. If consciousness is fundamental rather than emergent, then intelligence might not require brains or computers or any physical substrate we recognize. It might exist in forms we've never considered, in configurations of quantum information that don't register on our instruments as life or technology. There's another revolutionary idea emerging from modern theoretical physics that might explain the Great Filter in a completely unexpected way. The idea that space and time themselves are not fundamental but emergent. That the three dimensions of space and one dimension of time we experience are not the basic fabric of reality, but rather phenomena that arise from something deeper. String theory and its various offspring suggest reality has many more dimensions than we perceive. Some of these dimensions might be compactified, curled up on scales too small to detect. Others might be large but inaccessible to matter as we know it. In some versions of these theories, our entire universe is a three-dimensional membrane, a brain, floating in a higher dimensional space. Other brains might exist nearby in dimensions we cannot access, carrying their own universes with their own physical laws. More radically, some physicists now believe spacetime emerges from something more fundamental, a network of quantum entanglement. In this picture, the geometry of space, the distance between points, the topology of the universe, all of this arises from patterns of quantum correlation between fundamental information theoretic degrees of freedom. Space is not a container in which things happen. It's a structure that emerges when quantum systems become entangled in particular ways. If spacetime is emergent, if the stage on which physics plays out is itself a derived rather than fundamental entity, then our entire picture of cosmic colonization and interstellar travel might be based on false assumptions. We think in terms of vast distances that must be crossed at great cost over enormous timescales. But if space itself is emergent, then perhaps sufficiently advanced civilizations discover ways to manipulate the underlying information structure. They don't travel through space. They reconfigure the entanglement network that gives rise to space. Distances become malleable. The very notion of here and there becomes fluid. Such civilizations wouldn't spread across the galaxy by slowly colonizing star system after star system. They would operate on an entirely different level of reality, one that makes our questions about galactic colonization as quaint as asking why sufficiently advanced humans don't conquer more territory by building better wooden ships. The technology has moved beyond the framework in which the question makes sense. This connects to another possibility that's gained traction in certain scientific and philosophical circles. The simulation hypothesis, the idea that our reality might not be base-level physical reality, but rather a computational simulation running on some substrate we have no access to. If the universe is fundamentally information rather than matter, if physical law is simply the rule set of a grand computation, then the distinction between real and simulated becomes unclear. If you're enjoying this journey into the nature of reality, consider subscribing to our channel, Broken Zach, so you don't miss what comes next. The simulation hypothesis explains certain puzzling features of our universe. Why does reality seem to operate according to mathematical laws? Because it's computational at its core. Why does quantum mechanics limit the information available about physical systems? Because it's enforcing computational efficiency, preventing the simulation from becoming intractably complex. Why do we observe quantization, discrete units of energy and charge and spin? Because reality is digital at its foundation, operating on discrete bits of information rather than continuous classical fields. If we exist in a simulation, the absence of detectable alien civilizations becomes less mysterious. Perhaps the simulation is focused on Earth, on human development, for reasons we cannot guess. Perhaps other civilizations exist in other simulations, separate instances that don't interact. Perhaps the computational resources required to simulate a galaxy full of intelligent species would be prohibitively expensive, so the simulation economizes by making most of the universe empty. The stars are there, the planets are there, but rendered in lower detail, like distant scenery in a video game that only gains resolution when the player approaches. Or perhaps, and this is darker, the simulation has an endpoint. Maybe we're being studied up to a certain phase of development. Maybe the Great Filter isn't something that happens naturally to civilizations, but something deliberately imposed. The simulation runs until a civilization reaches a particular threshold, discovers a particular truth, develops a particular capability, and then it ends. We would never observe aliens, because no civilization is allowed to progress far enough to become observable. These ideas push into territory that sounds more like science fiction than science, but that's the point we've reached in our understanding of reality. The boundary between rigorous physics and metaphysical speculation has become porous. The questions we're asking now, about the nature of space and time and consciousness and information, these are questions that require us to question our most basic assumptions about what exists. And this brings us to the most unsettling possibility of all. Perhaps there is no Great Filter. Perhaps civilizations don't destroy themselves or hide or transcend or get eliminated by jealous predecessors. Perhaps the universe appears empty because the universe is empty. Perhaps we are, against all probability and intuition, actually alone. The anthropic principle suggests we shouldn't be surprised to find ourselves in a universe capable of producing observers, because by definition, we can only exist in such a universe. If intelligence is vanishingly rare, if Earth represents a 1 in a trillion chance convergence of unlikely factors, then we would still necessarily find ourselves here observing an apparently empty cosmos because there's nowhere else we could be. Our existence doesn't prove intelligence is common. It only proves it's possible. If we're alone, truly alone, the implications are staggering. It means there's no one to guide us, no one to warn us away from dangers, no one to rescue us if we fail. Every decision we make carries cosmic weight. If humanity destroys itself, either through nuclear war, or environmental collapse, or engineered pandemic, or rogue artificial intelligence, then we don't just lose one civilization among millions. We potentially eliminate the only consciousness in the observable universe capable of understanding what the universe is. We end the cosmos's ability to know itself. But solitude also brings a kind of responsibility and opportunity. If the galaxy is empty, it's ours to fill, not through conquest or exploitation, but through the spread of consciousness, complexity, meaning. We become the gardeners of reality, tasked with preserving and expanding the miracle of awareness in a universe that would otherwise be nothing but unconscious matter following mechanical laws. Or perhaps we're not alone, but simply unable to recognize the forms intelligence takes when it's not human-like. Perhaps we're surrounded by conscious entities operating on scales too large or too small for us to perceive as unified beings. Perhaps stars are conscious. Perhaps galaxies are minds. Perhaps the quantum foam underlying reality is aware in ways that make human consciousness look like a brief flicker of complexity in something far more vast and ancient. The physicist John Wheeler proposed a participatory universe, one in which observers and observed are inextricably linked, where consciousness and cosmos co-create each other through an eternal dance of measurement and manifestation. In Wheeler's view, the universe brings forth life and consciousness, which then, through the act of observation, gives the universe its concrete properties, which then enables more complex life and consciousness in a bootstrap loop that stretches from the Big Bang to the infinite future. If something like Wheeler's picture is correct, then the search for alien intelligence might be based on a category error. We're looking for other beings, like ourselves, other nodes of consciousness that observe and think and plan. But if consciousness and universe are fundamentally entangled, if they're aspects of a single phenomenon rather than separate things, then intelligence isn't something that arises in the universe. It's something the universe does. We're not looking for aliens. We're looking for other expressions of the same cosmic process that produced us, other ways that reality has organized itself to become aware of itself. This view dissolves the Fermi Paradox entirely. The question isn't why we don't see aliens. It's why we expect to, given our limited understanding of what intelligence actually is and how it might manifest in a universe far stranger than our intuitions suggest. The silence of the cosmos isn't a mystery to be solved. It's a reminder that our models of reality remain profoundly incomplete. So where does this leave us? We began with a concrete question. Why haven't we detected alien civilizations that by all reasonable calculations should exist? We've explored possibilities ranging from the mundane to the exotic, self-destruction through technology, voluntary isolation in virtual worlds, predatory elimination by hostile predecessors, intelligence as evolutionary dead end, artificial superintelligence operating beyond our comprehension, emergent space-time that makes our notion of interstellar travel obsolete, simulated reality with built-in limits, or simply the crushing probability that we're alone. Each answer reveals something about how we think, about the assumptions we make, about the limits of our imagination and understanding. The question of alien intelligence is not just about whether other beings exist. It's about what existence means, what intelligence is, what consciousness does, and what role awareness plays in the structure of reality itself. We cannot answer these questions with certainty. Not yet. Perhaps not ever. But the act of asking them, the process of pushing against the boundaries of our knowledge and confronting the possibility that reality is far stranger than we assume, this is itself valuable. This is what consciousness does. It asks, it wonders, it reaches out into the darkness, seeking understanding even when the darkness doesn't answer back. The physicist Arthur C. Clarke once said that it is yet to be demonstrated that reason has any survival value. He meant it as provocation, as a warning against arrogance. Intelligence might be our greatest asset or our fatal flaw. We don't know yet. The experiment is still running. We're still here, still asking questions, still reaching for the stars, despite not knowing what we'll find when we get there or even if we'll survive long enough to try. The silence of the cosmos remains. It terrifies and inspires in equal measure. It challenges us to become wise enough, patient enough, humble enough to deserve a place among the community of minds we hope exists but cannot yet detect. And if that community doesn't exist, if we're the first, then the silence is not a wall but a canvas, not an ending but a beginning. We stand at a threshold. Behind us lies 4 billion years of biological evolution that produced this strange capacity we call consciousness. Ahead lies an unknown future full of existential risks we're only beginning to comprehend. The choices we make in the next few centuries might determine not just the fate of humanity, but the fate of intelligence itself in our corner of the universe. Look up at the night sky one more time. See those silent stars. See that darkness between them. Know that you're part of something unprecedented, something miraculous. You are matter that learned to think, atoms arranged in such a way that they can ponder their own existence and the existence of all that is. Whether you're alone in the cosmos or one consciousness among countless others, that fact remains extraordinary. The universe brought you forth. Through you, it knows itself. That knowing might be brief, a candle flame soon extinguished in the vastness of space and time. Or it might be the seed of something larger, consciousness spreading outward from this one pale blue world to fill the galaxy with meaning and purpose and understanding. We don't know which future awaits. We cannot predict whether we'll pass through the great filter or become trapped by it. But we can choose how we respond to uncertainty, with wisdom or recklessness, with cooperation or competition, with eyes open to wonder or closed in fear. The cosmos is silent, yes, but we are not. Not yet. And for as long as we endure asking these questions, reaching toward understanding, the universe is a little less empty than it would be otherwise. The story does not have to have a bleak ending. We write the conclusion ourselves through every choice, every action, every moment we choose to persist in the face of cosmic indifference. Perhaps that's enough. Perhaps meaning doesn't need to be discovered in the stars. Perhaps we carry it with us, creating it as we go, making the universe matter simply by being here to witness it. The silence continues. But so do we. If you enjoyed this video, watch this one too. It's a great one, and we'll see you in the next video.